here's the story. The truck was an F-150 with a 4.2 in it. Belonged to one of the instructors on the other campus. And so he had a problem that it developed, and this is before I ever saw the truck, and it would lose oil pressure. In other words, when it got warm, it didn't have any oil pressure. So he took it to a shop, and they said, oh yeah, you got some bearings and stuff like this. And so he put bearings in it, I don't know. And anyway, they charged him $1,500. And so about 6,000, 7,000 miles later, he started losing oil pressure again. So he takes it back to the same shop. Hey, I'm losing oil pressure again. They said, well, that job was kind of hard on us. We just don't want to fool with it anymore. It's out of our warranty anyway. Just take it somewhere else. So he took it somewhere else. And they said, oh, they put some stuff together wrong. So they did a bunch more work to it, charged him $1,700. And so he said, well, 8,000 miles later, he's losing oil pressure again. And so he comes to me and he says, can y'all take care of this? I said, we'll be glad to. So we pull the motor out, put a crankshaft kit in it, cam bearings, oil pump, check, make sure all the oil passages were clear and everything. Put it back together, good oil pressure. He drives it 4,000 miles, and one day he said, it made a lot of noise. I said, really? So we got it in here, and it wouldn't start, and it was kind of locked up and all that. So we raised it up. The crankshaft I had bought, the crankshaft kit includes bearings and a crankshaft, right? The crankshaft that we put in there broke in half. Just without warning, poof, just popped right in the middle. And I put a picture of it up there on the board that I took. Now this is actually not Driveline related, but we're having a good time. So what I was going to say was, so the crankshaft broke. So I called the parts guy, and I said, the crankshaft broke on this engine. And he says, okay, let me check with the people I got the crankshaft from. And the crankshaft is like one of these over here that's got the offset rods, which there's the place there where it broke was really small. I mean, you can see right, let's see,
I've heard of the snout breaking off now.
No snout. This is not a snout thing. This one popped right in the middle.
Is this something that happens often? Is a crankshaft breaking? Because they seem pretty,
Correct.
See that? All right. That is the broke crankshaft syndrome. See that? See, there's the broke crankshaft.
That's crazy.
Yep, it is, isn't it? Isn't
broke right off at the bearing.
Yep.
I bet that sounds crazy.
Yeah, it's popped in half. All right.
Did it spin any of the bearings?
Huh?
Did it spin any of the bearings?
No, but I will tell you what it did do. When we put the engine, well, we got another crankshaft. Oh, Sam said that crankshaft's not guaranteed. That's what it looked like in the truck.
Huh.
Isn't that funny?
Yeah.
But look right here. See the way that the crankshaft the rod journals are offset, if you'll notice, like this one and that one. And it didn't have but this is football amount of metal anyway. But when they machined it, they said that particular type of crankshaft, we do not guarantee it.
Wow.
It was $210. And I said, well, now we've not only have we got a broken crankshaft, but we've also destroyed a couple of rods, and we got some busted pistons and other things because of stuff hitting in there. And so Sam, to his credit, he said, I did not know that crankshaft was not guaranteed. He says, and I will buy the crankshaft, and I will buy any of the parts that were damaged by the crankshaft. Which was a good deal for the customer, And so I said, okay, that's cool. So I took it apart. We got another crankshaft kit. We put all that stuff back together. We put the new crankshaft in there. When we buckled down the main caps, it locked up. You couldn't turn, I'm talking about with just the crankshaft in there, you couldn't turn nothing. So I get a straight edge and feeler. I couldn't tell that there was anything wrong. You lay a straight edge across all the mains and try to put it, and I couldn't feel it. But anyway, I pull the crankshaft back out, strip the block down, carry it over to the machine shop, have them line bore it. Which basically what they do when they line bore it is they take the cap, your main bearing cap looks like that. And it goes, and actually the other part of it's in the block. They take that and they shave some of that off. And they bring it down so that it's kind of egg-shaped now. It's smaller than it was by just a small margin. And then they go back through there and they make it round again. And it's just when they do that, after they line bore it, it actually uses the same size bearings. You'd think they'd have to have oversized bearings, but the way that they did it You just use,
Standard bearings.
well, standard bearings, but the undersize, I mean, on the crank side, they were smaller. The cranks was like, they machine the cranks out like 10 thousandths of an inch or 20 or whatever, you know what I'm saying? So the bearings that came with the crankshaft, we still use those. And we put that thing back together, and when we put it back together that time with some grease on the bearings and all that, buckle it down, and we could slap it, and it would just spin as smooth as silk. But we had to line, we're $325 to line board it all over. Then we built it back up with rings and put a couple of pistons in it. We put a new oil pump. You know, we had already put a new oil pump in it, and we put another set of cam bearings in it, just make sure. And it's still going. That's been like 6 years ago. He put a lot of miles on it. Now I don't know what was going wrong before. I couldn't tell when we took it apart. And occasionally an engine will just lock up for no reason. There was a 4.6 and a four-wheel drive Ford pickup truck, like a 99 model. The woman pulled it up into her driveway, got out, went in, got, the next morning she got in it and it was donk, donk, donk. And so we pulled it over here, and if you put a breaker bar on the doggone crankshaft, you couldn't turn it. It was just locked up. If you ever run into that, don't assume the engine is locked up, okay? Now in that case it was. But I've seen other times when I was working at the dealership, you put a bar on there and you pull on it, you're trying to turn it, it's locked up. And so then you take the belts off.
AC compressor lock.
Yeah, well, if you take the belt off and it still don't move, then you take the starter off. Because sometimes the starter the starter gear will foul up in there and lock it up. So take the starter and the belts off of it and then try to turn it again. You don't want to sell somebody an engine when they didn't need an engine.
And that's probably what most people do.
Yeah. Well, some people will do. I mean, some shops. I worked at a shop one time, and this is engine repair stuff, but it's good stuff that I'll forget if I don't tell you now. Where I had this came in skipping on one cylinder. It was one of these international 1.5 tons that you pull this forward, you know, to work on it. And I walk up in there and it's skipping on the front cylinder on the right bank, which is on that one, number 1, I guess. And so I said, okay, so because its firing order on that was the same as it is on Chevrolet or Dodge or something, you know. So I checked the compression. I've got no compression on cylinder number 1 at all. I mean, not a single pound of compression do I have, but I'm going to do a wet test. So I squirt some oil down in there. Now I've got 180. I went from having no compression to 180 pounds with just a couple squirts of oil. And I told the guy that was running the place, you know, that I was working for, I said, look, we're going to have to, I guess, pull this thing down and see what's going on, because, wet test means rings. I mean, that's just all there is to it. He said, well, okay, so he calls them up, and it belonged to a building supply place. And he said, well, it's been 5 years since we've rebuilt that motor, so go ahead, it's a gas burner, you know. They go in, put some rings and bearings and stuff in it. It's an in-frame overhaul, basically. You drop the pin, you pull the heads, you knock the pistons out and all that stuff. So as soon as I pulled the valve cover, I knew that I had fouled up, because somebody had over-revved that darn thing. It had floated a valve, and one of the push rods had come out of place and was laying down in the valley. Huh? Which meant that the intake valve, that was the one that had happened on, and the intake valve wasn't opening because it didn't have any compression, because it wasn't pulling any air in. However, when I squirted the oil in there and it sealed those rings real good, those really good sealed rings going down was able to pull that intake valve open enough that it was able, the atmospheric pressure was pushing the valve open, it would trap some air and look like you have compression. So beware of that. If you don't have any compression at all, and then all of a sudden you get a bunch, it's not necessarily, in that particular, the only time I've ever seen that in my whole career was that time. But I went back and told him, look, all I really need to do to fix this truck is put the push rod back in place. I mean, put the push rod. And I could, if I'd have pulled the valve cover before I went and talked to that knothead, then that's all I'd have had to do to fix that truck.
But he made you rebuild it.
But he made me rebuild it because they had already given him the okay. And he done money talks. I mean, basically, they'd say, yeah, go ahead. Well, we had their blessing to go ahead and rebuild it. Besides that, he knew, said, well, now when you put it back together, it back in place, everything will be fine, Anyway, but that was one of those situations where I felt like I had dropped the ball and kind of, I don't know. If you got any kind of a conscience, you're not going to put the screws to somebody. Although, they paid for an overhaul and they got one. And it had been 5 or 6 years since it'd been overhauled, and in their mind they
Yeah,
needed
but
it.
everything was fine.
Oh yeah, it ran great after that. Oh, there was one thing that it did have. It didn't have enough oil pressure when I put it back together, but there was nothing wrong with any of the bearings or even the cam bearings or anything. You know, because you put air pressure up in the oil gallery, and you put air, you know, with the pan off, you pull the oil pump off, and you go to a place where the oil pump pumps oil up in there, and you put air pressure up in there. If there's air hissing out somewhere around the cam bearings and all, you got cam bearing problem. Well, there wasn't on this truck. So I took the oil pump apart, and there was a spring in there holding the relief valve, and I put a couple of washers in there to tighten the spring on the relief valve, and we had good oil pressure. I should have put an oil pump on, but there's nothing wrong with the gears in the oil pump because I pulled that apart. But I noticed that the spring wasn't tight against that little relief valve plunger in the oil pump, and so I just went ahead and tightened it up a little bit. You know, you pull a pin and the spring comes out, and the plunger's in there behind it, and all that's operating freely. So I just tightened that spring up, and then we had good oil pressure. Anyway, that's old engine stuff. You don't typically see that kind of thing on new engines. And how did I get off on all that? But it was a good story. The Sprag clutch and roller clutch, we're talking driveline powertrain test 2 here, are 2 types of planetary gear sets used in automatic transmissions. No. Okay, they are not. That is a falsy there. False. Huh? Okay. A Sprag clutch and roller clutch. They actually are one-way clutches, okay?
I'm talking about the planetary gear set, Simpson and...
Oh yeah, you got a Simpson and Ravendo.
Yeah,
all that. Yeah, that's
a...
yeah. Okay. It's the combination of rotary flow and vortex flow that actually makes the torque converter function.
That's true.
That's true. Yeah, you guys, some of you guys that haven't had torque converter stuff, if I took 2 fans from out here in the shop, put them facing each other, right? I plug one fan in, I leave the other fan unplugged. Okay, if I got one fan blowing into another fan, what's the fan that's not plugged in going to do?
It's going to move a little.
Yeah, the air is going to make it go. Now let's put a shaft coming out of the fan that's moving, that's being driven by the other fan, and let that go into the transmission. That's basically what it is. Only you're doing it with fluid, and the fans are a lot closer together. And there's a stator in the middle that redirects the fluid to give you torque multiplication and all that. That's not complicated, to understand. But anyway, I just wanted to make sure everybody was on the same page. If a stator one-way clutch problem is suspected, a stall test or a bench test can be run.
Oh.
How? That's true. How do you run a bench test on a stator?
I don't know.
Torque converter stator. The part down in the middle, yeah, you got to go down there. You can get like the pump or a pump that will fit that torque converter. And you know that stator support is actually coming out of the front of the automatic transmission. You got a shaft with what looks like a shaft with splines on it, and then you got another shaft coming out that's got splines on it too. That's coming out of that one.
The one behind it.
The one behind it's a stator support. Okay, and what you can do is if you can take that transmission and you can go down in there with something to turn that, you can see if it turns back and forth. It turns both ways. In other words, it ought to lock in one direction. That stator support. That's the bench test. The stall test is going to be whenever you do a stall test. Remember that you put it in gear. You lock the park brake. You chock the wheels. You stand on the brake with both legs as hard as you can, or one leg as hard as you can, because you got to use gas on the other. Put it in gear and you forward the accelerator. That sounds scary, don't it?
No.
But you're doing it with everything locked, and you're going to see where the RPM stops climbing. That's your stall speed. Now, how many of y'all, been in a racing thing, you're talking about these stall speed converters, like a 3500 stall speed converter and all that? Why do we need that? What's the point of it? We want to be in our power band when we take off, not below it. So what we're going to do is we're going to have that a racing torque converter with a higher stall speed is a littler torque converter. If you see it, it's a little bitty thing. I mean, it looked like a torque converter, but it's thinner, and it's not as big. Yeah, but the point is that thing right there, that stall speed. If the stall speed is low, then the one-way clutch in that stator is not working, and you got to put a torque converter on it. Now, here's something else that can make a stall speed low: if the engine's underpowered, or if the exhaust is stopped up, or if you got it skipping or something like that, you're gonna have a low stall speed. If you know your engine's healthy, but you got a low stall speed, you're gonna have to have a torque converter. That's all there is to it. My shop foreman had an Expedition that he just hadn't owned all that long, and we were driving it to see if we could figure out which one of the cloths were bad. It had multiple cloths, I mean, I was just over there one day on a Friday, doing some stuff. It was well after I worked here. And so whenever you brake torque it, we was trying to get it to skip. It wouldn't skip. So we did notice that when we brake torque it, the stall speed on it was like 1600. And in the book, it's supposed to be 29 on that one. So if the stall speed is 1600, it's supposed to be 29. The engine's not underpowered. You got a bad torque converter. He didn't have a clue when he was driving the truck. Okay, I went on for a while, so let's go on. The Simpson gear set is the most common type of planetary gear set.
True.
Yeah, that's true. Planetary gear set is the heart of the automatic transmission. Different parts of the transmission hold and drive different parts of the planetary gear set. That gives you your gears. If I want to put it in reverse, what part of the planetary gear set am I going to hold?
The shell.
What?
The shell.
Not the shell. What? What part of it am I going to hold if I want it to back up? I'm going to hold the planet carrier. Think about it. If I hold the planet carrier and I drive the sun gear, the ring gear comes running backwards.
Oh, yeah.
Right?
The little gears is
Right.
very bottom.
So you can drive or hold the planet carrier, you can drive or hold the sun gear, and you can drive or hold the ring gear. That's what all these clutches are all about in the transmission, and these bands and all that kind of stuff. See, so every transmission operates a different way, but they all operate the same, but they all got different configurations and all that. Most of everything is pretty much the same. Okay, lockup chuggle refers to a vibration that occurs during a plow or release of the lockup clutch or after the lockup occurs. That's false. Chuggle is a word that General Motors likes to use. If you see the word chuggle, whoever wrote the test is a GM person. The stator one-way clutch can fail only if the clutch is constantly locked. That's false. It can fail either way. It can be constantly locked, or it can be freewheeling all the time and it still fail both ways. Most planetary gear checks are simple visual inspections for damage and wear. That's true. Once you get it out, you're going to be able to see. And some of the transmissions that when you rebuild them, like on some of these, like an RE401, I think it was, if I remember the Nissan transmission, the transmission buffs that are really, really gearhead transmission nuts have got a little fix where they take that separator plate that goes between the valve body and the transmission. It's got all the holes in it. And they know exactly which hole feeds the planetary gear set. And they drill that hole out just a little bigger so that the planetary can get more oil. Because the planetary doesn't really get enough oil the way that thing's built, or the way they were building them in the early 90s, in order to keep the planetary gear set from locking up. It's got to have oil squirted up there on it so it keeps it lubricated. And they were bad to burn up planetary gear sets. Well, if you drill that hole out, and it was something like 1/8, and you drill it out to 3/16, it didn't hurt a doggone thing. There's a lot more oil going up there, and it preserved the planetary gear set, right? Yeah. So,
Sometimes they're expensive too.
yeah, it does. If you think about it. Now, you don't want to just go in there indiscriminately drilling holes out bigger. You know what I'm saying? You got to know which one you're drilling. And they had a little schematic of that plate, and they would show you, this is the hole you need to drill out, because it looked like Swiss cheese, Now, these other guys that are building this RE401 that we had in here, they had to clean the valve body a bunch of times because some trash kept getting in it. Anyway, it had one particular place where there were two holes, and this ball was supposed to roll back and forth between them two holes. It was a shuttle ball, or whatever you call it. And they got in a big hurry. They had like 7 or 8 balls, and they put a ball in each place instead of putting just one ball that would roll back and forth. And this was just fine as long as they were taking off in the parking lot. But when it shifted into second gear, it would lock the wheels up because it was going into 2 gears. So I had to pull it back down and said, "You guys put a ball in both of them places." Yeah. Okay, well, whatever. Anyway, we finally got that one going, but it was a pain. Let's see. The Ravino gear set operation is the same as the Simpson gear set operation. That's true, pretty much. The primary cooler for fluids in the transmission is located beside the transmission.
False.
Wrong. Although you can, now this is another thing. If you, let's say that you pull a transmission apart and there's all kinds of metal in the pan. Right, lots of metal in the pan. Okay, to begin with, you got to recognize that the metal is in the pan. Where does the fluid go? I ask you this during automatic transmission. Where's the heat generated in an automatic transmission? Where's the heat made? Torque converter makes the heat. So we're leaving the torque converter area with the fluid. We're going to the transmission cooler, and we're going to dump it back in the pan. Of course, the pump feeds the converter, and then that pressurizes up, and it pushes pressure out. You got line pressure and governor pressure, all that other stuff. But the fact is, if the splines in that torque converter strip out, and they'll fill up the doggone, or if there's anything else that's, got fluid metal particles, they'll fill up that transmission cooler with metal particles. And you may take that transmission out, and you may put another one in it, like a crate transmission, or you may take it apart, and you may clean everything up, and you may rebuild it, and you may clean the valve body, and everything's perfect. But as soon as a lot of those metal particles come washing out of that transmission cooler back in there, you're back where you started. Everything ain't burned up. It takes off going down the road just fine, then it will shift out of high gear when you come back, and all that kind of hogwash because the valves are stuck in the valve body because they got metal particles in them. And it's going to get past the filter, some of that stuff is.
That's the
All right, so what you're doing is, you got to take, if you're going to do that, if you got one that's got a lot of metal in the pan, you need to do one of two things if you're going to be wise. You need to replace the radiator, just on general principle, and blow those lines out. The big long lines that go to the radiator. Before you hook them to the transmission, take them loose from the radiator, blow them out, put some fluid in them, blow again, make sure there's none of that in them, put a brand new radiator in it, and you saved yourself from that. Or put one of those external transmission coolers, where you run the hoses from those out to this thing that's got fins that you buy for $29 at the parts house. That'll take care of that too.
Sir, could you take the transmission cooler off the radiator on a late '90s Chevrolet?
Some of them have got an external cooler, some of them don't. I didn't look, but you can't take it out of the radiator without taking the radiator apart. If it's one of those that goes to the radiator,
That's what's holding me back from putting my transmission back in is having to clean out that, and I ain't got no way to get it to work.
If you can afford it, throw a radiator, or put one of them external coolers. Bypass that one and put an external cooler on it. You'd be okay with that.
Ain't that much.
They don't cost very much. Oh, Archie, he knows. All right. Now then, let's see. The most common type of in-vehicle test is the converter leak test. That's an in-vehicle test. A converter leak test means that you're going to hold the converter there, and you're going to have a sealed plate that you got clamped down there so that you're going to put air pressure in the torque converter. Fill the torque converter up with oil, put air pressure in it, and see where fluid comes out.
So that's false?
Yeah, that's false. That's not a common in-vehicle test. You can't do a converter leak test in a vehicle.
No.
The flywheel that the torque converter bolts to, that thin metal plate, they call that a flex plate because the torque converter swells up a little bit when it gets pressured up. And that plate has to flex. Well, the problem with that is sometimes that doggone plate cracks around the bolts and stuff, and it'll make noise. Matter of fact, I may have one over here that's cracked. That we changed out. And I'm probably not going to be able to find it. Oh, wait a minute, yeah. Two of these. Two cracked flywheels. All right?
Yeah, a bunch of those.
We'll pass these bad boys around. I noticed when I was watching Transformers the other day that you could see the clutch and the pressure plate up on this one of them's back, whenever. All right, now this flywheel right here, you can see the cracks right there.
I mean, I see what's.
Now this right here came out of a Pontiac Alero, a 99 model. And this thing drove us up the wall for a while. It was making a noise. It was making three different noises. And we got all the noises straightened out except for one. And it was in a different spot than we'd been used to listening it to. And whenever it was bop, 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 and it didn't do it until it got hot. And so whenever I'm hearing up on the lift, I get my stethoscope, I'm holding it up here in the flywheel area, and I'm hearing this tick, 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 tick. Yeah, I know what that is. Well, we pulled it out and found this flywheel crack. There, you hold that.
How audible is the noise?
Pretty darn bad. It sounds like an engine knocking almost. I tell you something else. Bobby Messick, this guy, the maintenance man, he said that he had this Cummins diesel in an 89 model truck, had 540,000 miles on it, and it started making a racket. And so whenever he says, well, it's got a lot of miles on it, I'll probably go ahead and put a motor in it. And so whenever he pulled the motor out, he noticed the flywheel was cracked. He didn't have nothing wrong with that motor. It had 540,000 miles on the cracked flywheel where the noise was. And he kind of missed out. He's doing it at home. He doesn't work at home. But, all right, now here's another one. And this one here came out of a 2000 Chevrolet Silverado with a 6-liter in it. And I got little arrows drawn to the cracks. And this one was one that we did on the Industrial Electronics Instructor's truck. It was making a racket, and it kept getting louder and louder and louder. And whenever we pull the cover off where you can see, here, you can stick your stethoscope up in the flywheel area, and it's noisy as all get out. And it's the tick, 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 you're thinking, what is it, lifters or whatever? But it turned out it was this. And you can't see nothing up in there, but you can hear it. If that's the loudest place, then you know you got a cracked flywheel. Or that one there's not quite as easy to spot as that other one, so pass that around too.
Wouldn't it
Okay.
be pretty hard to crack it though?
Huh?
Wouldn't it be pretty hard to crack it?
Well, it's cracked because of the torque converter continually swelling and flexing it. See what I'm saying? And if it ever breaks completely out, because somebody ignores the noise, then it's going to screw up the hub on the torque converter and start it leaking. I've seen that before. And these darn things, and sometimes that button on the front of the torque converter that goes in the back of the crankshaft, it'll leak transmission fluid around there. So just because you got transmission fluid dripping out of your transmission bell housing doesn't mean that the front pump seal is a problem. And listen to this. If you pull the transmission out and you look at the front of that torque converter and it's wet with transmission fluid, you best be suspecting a leaking torque converter. Because where's the fluid, where's the seal? It's behind the torque converter. It ain't going to wet the front of the torque converter. Unless something stupid's going on. Okay. Now then, here we go. Let's see. In a synchro mesh transmission, the gears slide into and out of engagement. This is a manual transmission. No, they don't. They actually don't. They're always engaged, but you have these synchronizers that, that move back and forth that, change the gear ratio. Okay, we got about another 5 minutes to go here. The number of internal shafts in a manual transmission depends on the number of forward speeds. True or false? Come on, guys. That's false. All right. The large gear ratio multiplies torque. That's a kind of a silly thing. Large gear ratio. What do you mean large gear ratio? What if it's 4 to 1?
You got 4 turns of
4 turns of the engine and 1 turn of the drive shaft. Yeah, that's multiplying torque, isn't it? That's a large gear ratio. Okay. In low gear, the drive gear has fewer teeth. Huh? That's true. In low gear, the drive gear has fewer teeth than the driven gear. The drive gear being the one that's attached to whatever is providing the power. That increases torque, reduces speed to the drive wheel. So if the drive gear has fewer teeth than the driven gear, think about it. Think about your 10-speed bicycle. What happens when you go into your higher gears? Is your chain walking out to a bigger gear on the back or walking into a smaller one? Right? All right, let's look at this and think about it. You guys are kind of locked up on me. Brandon, you need to be thinking about this. This is your question to answer. And you have 2 choices, true or false. Okay. Are you going to guess it? Read it now. Read it.
I'd say it's true
Because?
you need a bigger gear because it needs more torque to take off, and the faster you go, you need less torque because you're higher speed.
Yeah, so you're going to start off. Well, how many of you drove a go-kart? With them silly little pulleys that go back and forth. All right, now what happens whenever you let off the throttle and you're sitting here? How are your pulleys positioned? The front ones are far out, and the belt's riding close to the center, and the back ones are close together, and the belt's riding close to the outside. What does that do? That gives you more power to take off. And then as you pick up speed, the front pulleys go together, the belt walks out, and that forces, because of the belt can't stretch, the forces the back ones out. So now you've got the big pulley in the front driving the little pulley in the back, you got speed. Got it? All right, so let's look at this number again. Let's see, in low gear, the drive gear has fewer teeth than the driven gear. Okay, think about a starter. The starter's got a 14 to 1 ratio there, doesn't it? The starter's got a little bitty gear, which ain't very many teeth, usually 9 or 10, and there's 14 times that many teeth on the ring gear. How many of you guys have ever changed a ring gear on a manual transmission flywheel? Manual transmission flywheel, a little thick and heavy. What you do is you take the torch and you cut that gear, and it falls off of there. And then you take your new gear, which you can buy just the gear, and you lay it on there, making sure that the chamfered side of the gear is pointed toward the starter, and you heat it with a torch. Just keep heating it real even with a torch, and you heat it and heat it and heat it, and it drops on there.
Some of them you can do that.
Yeah, it goes on there.
Nowadays, most of them are welded on.
Yeah, a lot of them are. But I mean, I've changed a bunch of them. Well, you can also knock it off of there with a punch if you go around it, beating on it, knock it off.
Breaking the wheels.
Huh?
Like breaking the wheels.
Well, yeah, the welds, the ones that I'm talking about weren't welded. They're just actually sweated on there. Whenever they put a wagon tire on these wooden wagon wheels like they use in the Western movies, that big wagon tire is a band around the outside of the tire. They make the wheel, and that wagon tire is kind of too tight for the wheel. I mean, you can't just put it on there. you build a bunch of fires in a circle, the blacksmith did, and he'd heat that thing up. And then he'd get his tongs and he'd set it down over that wheel so that whenever it dropped in place, he let it cool off and it would tighten up on that wheel. And it helped the wheel stay together. And it also, provided that, you couldn't just have wood there bouncing over them rocks. Dump your wife with her bonnet and her youngest go over which way. All right. Now then, we got, let's see. So 14 is actually going to be true after we had that long talk about it. The most torque is needed when the vehicle is moving quickly.
That's false.
Wrong. When the driver shifts the transmission into high gear, engine speed increases. No, that's dumb. The synchronizer sleeve connects the transmission to the shift lever.
That's true.
Well, you could make a case for that, but the correct answer is, according to our textbook writer, is false. Some of these questions are poorly written. Cable linkage is the most common type of transmission shift linkage.
Depends on what it is.
Yeah, really. I don't like that question either, but if you want to get it right when the girls grading them, put false down there. Before disassembling a transmission, you should inspect each component for damage and wear.
How you do that with the assembly?
Yeah, exactly. You got to take it apart first, don't you? That's a false. The installation process for a transmission is the same as the removal process. No, whenever you're putting it in, you screw the bolts in, and when you're taking it out, you screw the bolts out. You guys that are you newbies know that when you're moving a bolt, you need to turn it in the direction. Hold on, you're making me too loud here. When you move a bolt, you move it in the direction you want it to go. If the bolt is facing away from you, and you're going to take it out, you need to turn it in the direction to carry it away from you, right? So don't get confused by that. Newbies mess up on that. Of course, I don't have any newbies in here. You guys are all old.